big slope, what's my line going to look like? So let's see, is this a really big slope? No. So a really big slope would be like that, wouldn't it?
Almost like.
And then bigger would be like that. So do you see if I get straight up and down, that's the biggest, that's infinite. That's another reason why we call it infinite slope. This is bigger than any number you can imagine. Is a straight up and down.
90 degrees.
I like it. So I can 90 degrees to that. Cool. Straight up and down. Sweet. I like it. Okay, cool. So, shoot, I erased my earlier picture, but oh, we'll do it again. So remind me real quick. If I had a point here, and a point here. What point is this?
0.
1. I'm not on the axis, right? I'm up 1.
Yeah, sorry.
Put it up higher. There. I'm up 1. And then what point is this?
2, negative 3.
2.
Negative 2,
Negative 2. Okay. And real quick, I might as well be very... When you make graphs, you really should give me scale. Because it won't always be by ones, hopefully. Yeah. So show me what the scale is, yes.
Were you, seeing you graphics, are you doing something else with that?
Yes.
Okay. Okay, I was like, what?
I like it. I like, move along, Jeff. All right. Plenty to see here. So to do this visually, I just have to do what we did earlier, right? I would go down so much, you know. What would the slope? If I go down, how much do I go down? 1, 2, 3, right? Seem to be out. 1, 2, 3. Is that cool? So how do I represent that in my slope? Negative 3, because I rose negative, which means I fell. So if I fall, it's a negative rise. If I go backwards, it's a negative run. I like it. Because the slope should be... Is this good news for your company if this is your profit? No, this is bad news. It should be negative slope. Right? It's going down, Johnson. Boy, Johnson. So negative 3 over what?
5.
Positive 5, right? Because I ran in the positive direction. So it's positive 5. So it's a negative 3 for the slope. So I should be able to do that exact same work without the picture. I shouldn't have to draw the picture. If they just give me, find a slope between negative 3, 1 and 2, negative 2, I should be able to do that algebraically. And really, if you think about it, how much did this change is the difference in the what?
What?
Y's. And the beautiful thing about it is, it rhymes. What was slope again in words?
Rise over run.
Rise over run. Rise is a change in Y's. You can't beat that shit. It rhymes. The run is the other one. The X's. Right? Still rhymes. Rise is the change in Y's. I don't know if you've ever seen this symbol before. Yes? So that means change in. Run is a change in X. So change means what? How do I figure out how much this changed? And what operation means the change in something? How different two things are. Right. Subtraction is crazy, right? So this would be y2 minus y1 over x2 minus x1. What is y2 and y1? What the hell is that shit? Yeah, so if I say this is the first point, I can say this is x1 and y1. So this is amazingly enough x2 and y2. So these little subscripts, they aren't powers, you don't square them. They're just labels. The ones for the first point, the 2's are for the second point. So how do I do this algebraically then? What's y2?
Negative 2.
Negative 2 minus y1. And here's where everybody screws up. x2 is 2 minus, what's x1? Negative 3 is a minus and a negative. Right? And your brain sometimes says, I already wrote a negative. No, you didn't. You wrote the minus. You got to write the negative. So this will be what? This will be negative 3 over
negative 6.
2 plus 3.
5.
5. There's no multiplication down there, right?
Oh, yeah.
It can't become multiplication. I like it. Which is exactly the same thing we got over here, of course, right? So please, dear God, some of you guys right now are like, why don't I just always do this? 2 reasons. 1, you shouldn't have to. There's an algebraic way to do it. You shouldn't have to draw the picture. And 2, what if your points are disgusting? What if your points were 11/7, comma, 2/9? Visually it would suck. You go down 38/49, and you go, no. I'd rather just do the subtraction and just let the algebra happen. Yeah.
I know this might sound like a dumb question, but how do you know, is it because of the quadrants?
Oh, no. I love it. Good question. Very good question. Not a dumb question. Why did I call this the first point? Because I happened to write it first.
Oh, okay.
If I had written the other way around. If I call this one the second point, what happens to the slope then? It'll be -1, it'll be 1 minus -2. Are you guys with me? If I just turn them around, it'll be 1 minus -2 over -3 minus 2. Which is 3 over -5, which is -3/5. It's the same damn thing.
Oh.
So some of you guys won't understand this. It sort of sucks that we have to write this in here because it always confuses somebody somewhere. But the only reason this is in here is you have to go the same direction. So if I do this one minus that one, I must do this one minus that one. If I do this one minus that one, I must do this one minus that one. That's really the only reason that those are in there. If I go the wrong direction, I've got the opposite slope of what I'm supposed to. Yes, sir?
How do you find the slope when the points are fractions?
Oh, the same way. Sounds exciting. So what if I had the points? I think it's 11/4, 2/9, negative 3/2, and 1/3. Ooh, yummy. This becomes sort of busy work with fractions. And of course, some people won't even write that down in the homework. No, hopefully he doesn't notice I skipped one. I always do, so don't try that shit. So how do I find the slope? The slope doesn't give a shit about the fact that there's fractions in there. How do I find the slope always? You pick, what definitely goes in the top?
Right.
The y's. So which way do you want to subtract?
3 minus 9.
Where?
1/3.
1/3 minus 2/9. Okay. So if you go that way, 1/3 minus 2/9, you better do -3/2 the same direction. Does that make sense? That's the only reason the formula is the way it is. That minus that, bam. So that minus that better go here. You can't just pick and choose which way to go. You have to go the same way. Oh, that looks yummy. That looks like one I'd give you. Because it's just, you got to know how to deal with fractions. I'm sorry. You don't get to cop out on that. Oh, I'm just the person that doesn't know. No, screw that shit. You can know fractions. You know what you need here. Don't give me this bullshit about this is -1/6. Right? And then somebody say, no, it's +1. Say, no. What do you need? LCD. Yeah. We know this. So how do you get him to have the same? There's 3. So I get 3/9 minus 2/9, 1/9. Is everybody with me?
Yeah.
On the bottom, same thing. So I need to do what?
4, 2.
So I need a 4. So yeah, multiply by 2. I like it. So -6/4 minus 11/4.
9. -9 or negative.
-6/4 minus 11/4. -17/4.
7.
Yeah.
And it's okay to leave it like that?
No, I'm just making sure everybody's with me. I heard it. Wait.
Well,
I love you
no,
guys.
because it's -6 minus 11/4.
Yes,
So you're taking that minus as a negative?
it is. Because I can write it like that. And again, if I have -6 of something, and I take 11 more away, now I'm 17 in the hole, right?
Yeah.
I owe you 6, I owe you 11. Shit, now I owe 17 total.
Yeah.
I owe 17, yeah.
Okay.
I like it. And what do I do? This is definitely a very good point. You definitely do not want to leave this like this. But this is nowhere near as hard as it looks. 1/9 divided by this, I can write like this, right? And of course, how do you divide fractions? Multiply by the reciprocal. So 1/9 times 4/17. Nothing's common, so I just 4 over.
17. No, 9 by.
Oh.
What's 10/17? What's 10/17? 170. But I only went 9/17, so what's 170 minus 17?
153.
Or, you got your calculator.
What about the negative?
Yeah.
Negative. Where's the negative? Oh, yeah, I left the negative on. Thank you. Good. Cool. So, yeah, there will be a couple, at least, with fractions in them, because that happens in the real world. All right. Any questions on that? So the process never cares. I keep trying to say this. We learn a lot of processes in math, and they don't care that there's a fraction, there's a letter, there's a variable. The process don't care. You do the same thing. Y2 minus y, 1x2 minus x. I like it. So, what do you think is true? I already said this about that. So a horizontal line has what kind of slope? Zero slope, right? And a vertical line has infinite slope. I love it. So those are our two special cases.
Excuse me, for that, do we have to put this on always? Slope.
Yeah, if I give you 2 points and I don't give you a picture, yeah, I'm getting there. If I give you 2 points and I don't give you a graph, you need to use this equation.
And change y, change x.
You don't have to. You don't have to do this step. I just put that in there in case you see that symbol, so you know what it means. It just means changing. You see the little delta? That's a Greek letter delta. It means changing. Okay. So the last thing we'll do today. Your favorite phrase. Is to make a connection between the equation and the slope we just did. Well, actually, let's do this. Yeah, so let's work our way there. Let's say I told you a line goes through 1, -2, and has slope m equal to 3. I like it. Let's see. We haven't talked directly about this kind of problem, but I want to see if we can try to graph that line. Did I give you an equation? No, but I gave you better stuff than that. I gave you better information. Just can you graph that line? Try something. I'm never going to see what you're doing. So just try something.
No. Because this number I don't know.
But I don't want the equation. I just want to get the just to help you guys out a little bit. What's underneath the 3?
1.
1. Interesting. Like, oh wow, Jeff, thanks.
So, did you say we count where the dot is? The next one is 1.
Yeah, how many steps from that?
Okay.
1 step, yeah. So if you're on the dot, you've taken 0 steps. Alright. Let's see what we got here. So, something that came out, I haven't said this yet, but this is a nice way to think of it. The slope tells me how to get back to the line if I start on the line. So it's sort of like if I'm going hiking and I wander off the trail, the slope will tell me how to get back to the trail. So if I wandered 3 feet off the trail, the slope will tell me, okay, you got to go 7 feet this way to get back to the trail. It gets me back to the line that I'm supposed to be on. So if I'm at the point 1, -2, where's that?
Down.
Right 1, down 2.
All right. Cool. And then slope is 3/1. Of course, slope is in English rise over run. So from here, I don't start there. It's not a point on the line. If I start on the line and I do what the slope says, I'll get back to the line. And I don't even know where the line is. So if I do what the slope says, I'll find where the line is. So what do I do? 1, 2, 3. Over 1. What point did we get to?
1, 2.
No? 2, 1. It's always got to be x, y. So that we all talk about the same thing. It's always in alphabetical order. I like it. You guys? So that's a very basic skill right there. So think about this then. Let's analyze this real quick, and then I think we'll head out. So this is in the form mx plus b. And in that equation, what is b? No. What is b? What's the value of b? Negative 3. Right? Because it's plus b, and since it's minus 3, b must be negative 3. And what's the value of m? 2. It's crazy. And we talked a little bit earlier, but if I changed x by 1, y is going to change twice that, right? The number in front is the amplifier. I like looking at that. It's whatever x does, that number in front is going to double it in this case, or make it smaller or bigger. So if x changes by 1, y will change by positive 2. And if you made the table like we did earlier, we can do that thing we did earlier, x changed by 1, y changed by 2. We can see it happening, but I don't want to do that. I want to get more directly to the point. So then I know the slope is 2 over 1. Slope is change in y over change in x. I know the slope is that number. So whatever that number is the slope. I know most of you guys should know that, right? So the slope here is 2. And this number, some of you guys started to tell me what it actually is. What is the b always? What is that number in this case? Y, because if I make x 0, y equals b. So whatever the hell number is there has to be the y-intercept. So how do I find the y-intercept? And make x 0. When I make x 0, I get whatever the hell that is. So the y-intercept for me is,
Negative 3.
and I'm going to be a real dork, the y-intercept is not negative 3, it's 0, negative 3. Oh, Jeff, so picky. I'm a math teacher now. Just to save you from yourself later. If you say it correctly now, you won't make some silly mistakes later.
B equals y-intercept.
I like it. Whatever the value of b is, if it's in this form, then that's the y-intercept. So real quickly, if I had this, is the y-intercept negative 1?
No.
Hell no. This is not in the right form, is it? Then divide by 3, and then I can see what the y-intercept is, something gross. Right, negative 1/3. If it's in this form, I know a lot. So can I graph it? What do I do with this?
Go nowhere. And then go down.
I like it. Look at that. It's beautiful. It's a perfect way to say it. And then up 2 over 1. Up 2 over 1. All right. You can do that till you go crazy, so we'll stop. That is the line for this. That's this visualized. So what point is this?
2, 1, negative
2, 1, right? Is that cool? So when I plug a 2 in, what do I get? 2 times 2 is 4, minus 3 is? Holy shit! So that's what I mean. I didn't calculate that point, did I? I just counted up to it. So any point, I love these 3 guys are, wow, Jeff. But some of you guys don't even realize that's what's going on. When I graph this line, every point it goes through works in the equation it came from. That's the whole point. That's the visualization of all the answers to this. And that's plenty for today, I think. All right, so I said this before some of you guys got here. I'm planning on having a quiz on Thursday.
This Thursday?
This one.
This one?
Yeah, there's plenty of time. Today's Tuesday. Quiz on Thursday through section. Yeah, we just got in a slope today. So through section 3.3. So 3.1 through 3.3.
3, 1, 3, 2, 3.
Yeah. And just to come back, my earlier statement about some people that have not, some of you guys have, I was thinking about my other class. They're on my brain too much. Bunch of little cheaters in there.
Turn in all their homework.
Some people did turn in all the chapter 2 homework. I said earlier, nobody had, but some people.
Okay.
Yeah. All right.
It's just